We have Becky Lewis from EnergyDeck, who's going to be talking to us about building distributed systems. Over to you, Becky.
If, of course, I can manage to not knock out the projector. Yeah. Hi, welcome to Pycon UK. My name is Becky Lewis. I've been coming to Pycon for several years now, so I thought I'd actually get up this year and try and do a talk. This is my first conference talk, so please bear with me if I stutter around a little bit. But my talk is distributed systems from scratch, lessons learned the hard way. So for the past couple of years, I've been getting more into creating more distributed systems, moving away from monoliths. And of course, when you start to do that and you've not got a lot of experience, you make an awful lot of mistakes. So hopefully this talk will be useful to some people here who may be starting off writing new systems. Over the past couple of years, I've heard a couple of talks more focused on how to break up a monolith. So I thought I would avoid that because I think there are an awful lot of lessons to be learned when you actually try to write something from scratch. It might sound easier, but there are certainly different challenges. And in fact, there is, I believe, a talk on breaking up a monolith tomorrow at 5 o'clock. Okay, I'm not sure why that's happening on that screen, but that says infrastructure, provisioning, and deployment. Now, when you first start a project, probably like me, the first thing you actually want to do is start setting up your local environment and starting to actually get things running and start writing some code. So one of the first things I learned last year was don't just jump into the code. The code is really important naturally when you're doing software development, but as you're doing distributed systems, you're going to find out more and more that actually system operations is really, really important. If you don't get your sysops right, you're going to be scrambling at the last minute. All of your things aren't going to work together, and you're really going to have a bit of a mess on your hands. So the first thing I started off with my latest project was to actually just do infrastructure as code. So the aim is to completely have hands off of the servers. You don't want to be touching servers if you're doing distributed systems. That's probably not what everybody is used to. I certainly wasn't. There's lots of tools to do this. If you're on cloud systems, it's much, much easier. There are tools such as Terraform, CloudFront, and you really, really need to make use of these. I don't know if anybody here is using anything like that. Yeah. So what you need to do is start this from scratch. Anybody who's used Terraform will already know. If you don't do this from the beginning, it's really, really hard to backtrack later. You don't want to be backtracking when you're doing your system operations. It's almost impossible if you've already got a production system running to then start implementing something like Terraform into the mix, because you're probably going to do what I did and take down your production server by accident. Something else I noticed about setting up all the system operations is that the more you do it, the more systems you have running, the more individual pieces you have, the more centralized your system operations is going to have to become. So it's not just about infrastructure as code, it's about making sure you have the entire system automated. Apologies. You also need to have separate steps for everything. You need to have your infrastructure separated from your provisioning. You need to have your provisioning separated from your deployment system. A lot of people I see writing their automation scripts are actually writing really long pipelines and not split up properly. You don't want to do that. What you need to do is actually make it modular. Write it like your software. Make sure that every single part of it can be run individually, because otherwise you're going to end up in a position where you actually just want to push the code, but actually you've tied it into your infrastructure build, which means it's going to take longer, but it also means if you want to change something about your infrastructure, you have to run your entire deployment. That's not a good position to be in. So your deployment does need to be there by itself. It needs to be running without all the rest of the guff around it. Your servers need to be provisioned already. It doesn't really matter if you're using containers or you're going on the bare metal. Make sure that if you're pushing your containers, you're not doing any provisioning at the same time. If you are just deploying, if you're running on the bare metal, that you can do it without needing to install any software. So once you've written your infrastructure as code, once you've got your provisioners running, whether you're using Salt or Puppet, whatever, and you've got your code going up into the server, well, what's left? What else do you need to do? Well, actually, you've got to make sure you've got everything centralized. I'm sure people here are using CI, continuous integration. But you also want to be doing proper continuous delivery. Now, a lot of these CI tools will do continuous delivery somewhat, but they don't tend to do it in parallel. I would really, really, really recommend getting a proper continuous delivery service. I prefer something like GoCD. I believe that Jenkins has some plugins to do CD, but you really want something that can run in parallel if possible. If you have all these pieces in place, you actually get a really nice bonus, which is you have complete disaster recovery set up already. If everything is automated, you should be up and running very, very quickly, depending on the scale of your system, of course. Now, that says logging and monitoring. So, I don't know about you, but quite often I leave all of my logging until the last minute, which is really bad. And monitoring is traditionally done by your system operations team if you have one at all. But both of these are really important if you're doing distributed systems. You cannot do anything distributed if you can't tell what's going on. If you're jumping onto a server every time you want to look at your logs, you're going to have a nasty surprise when you have 5 servers running, you have 16 different services on those. Trying to find a problem in that haystack is impossible. So the best way to solve this issue is to just get some centralized logging aggregation. Now this can be hosted by yourself. I actually quite like using the Elk stack. For those that don't know, that's Elasticsearch, Logstash, and Kibana. Those 3 things together allow you to have a really nice searchable dashboard. So you can put all of your logs in one place and you can search them. That also brings up a point. how do you follow logs through? How do you do your searching on them if all you're doing is firing logs at a server? Well, the answer is make sure that you put a unique ID on any entry point for your logging. So when you start a process off and it's going to pass it down a whole pipeline, just put in an ID at the start. And then everything that's doing the logging can check, is there an ID? Yes. And it will use that ID with your logs. If you do that, then it's very, very easy to trace something through your entire system. Now, I know a lot of people don't like to do sysops because a lot of people here will just be developers who want to get on with the actual work of developing systems. So there are an awful lot of really good hosted solutions for this. You don't have to set up your own stuff. Of course, they will charge you for the honor, but it's well worth the investment because your time is more important than anything else, really, and you want to be developing with your time. You don't want to be tracing things through a huge logging stack. Now, likewise to needing to be able to follow your logs, you want to know when things are going to go wrong. Ideally, you want to know before they go wrong, so you can fix them at that point. This is where monitoring servers come in, and they come into their own really, really well. For example, if you suddenly start getting a whole bunch of 404s on your checkout, you kind of want to know that before somebody rings up your call center and complains at you. So if you start looking for patterns of things that aren't quite right or quite normal, you'll get alerted to problems before they actually turn into bigger problems. And quite often you can find out issues before your customers do. So get monitoring in place. There's many tools for this. Again, if you want to host yourself, you can use Nagios, you can use Zabbix. I'm sure there are others around. Those are the two I am most familiar with. But if you don't mind the cost, again, there are others. New Relic, which is a wonderful tool, but super expensive. This Datadog, which is actually a lot like New Relic these days. We found it quite useful in the past. And all of these tools can help you to locate patterns in what's happening. They can all help you to find sort of inconsistencies in what's going on. They can also help you backtrack. Perhaps every 2 weeks you get a huge spike in your CPU usage at 2 o'clock in the morning. It's really useful to know that that's happening. It might not even be breaking anything yet, but it's something that you can go and actually respond to. That says, you never used to take this long. Probably the biggest lesson that I have taken away building distributed systems from first principles isn't a technical one. It's actually managing your managers. There is so much more overhead when you are dealing with distributed things. Not because they're distributed, but because you have all of this other stuff to do. You have to have your monitoring, you have to have your logging, you have to completely automate your entire infrastructure, your deployment, everything. So this was actually quite a recent thing for me, as I'm sure my CEO will tell you. How to explain to somebody why you're taking so long. It's really important to get buy-in from everybody. They all have to know that you have all this extra overhead. They all have to know that actually that text change might take longer. Or, well, actually if we want to build another piece of this, it's not going to take 2 hours, which is what the coding would usually take. It's going to take a day. So this is the biggest takeaway that I've had, is to make sure that everybody involved knows that everything is going to take longer because there is more to do. But at the same time, you also have to be able to explain to them why that's a good thing. And that's really hard to do, because all they see you doing is playing around, having some fun, building something that they think is a little bit monstrous. So it's really difficult to do, but if you can, make sure that you have buy-in from every level, from your technical project manager. And technical project managers, surprisingly, quite often don't understand that it's going to take longer. So it's really, really important to make sure that everybody from the project manager to the CEO, anybody who's going to come and give you hassle, actually knows why it's taking longer. And that it's a good thing, that it's going to actually decrease costs over time. That says, monoliths are sneaky beasts. Luckily, I didn't manage to go full on and create a complete distributed monolith. We got really close though, and oh, don't do it. Be so careful. If you are starting to have to deploy two things at once because they rely on each other, stop there, backtrack, and just separate them, please. We did find ourselves in quite a terrible situation where we did have three things that we needed all up at once. We couldn't do it. And we ended up with just errors every time we were deploying anything. And it just snuck up on us. We all know very, very well how to build things in separate pieces. But, you know, you just make a little cut corner here or there, or you go, well, you know, it can't really hurt this time. But you will end up with a horrible ball of mud. But it's going to be distributed, and it's going to be really hard to deploy. So don't do it. Just keep an eye on everything. If you do start realizing that you're deploying more than one thing at a time, stop, review it, get rid of that problem. And we're at the end.
Thank you very much, Becky. Any questions, anyone? We'll start at the front here and then one at the back there.
Hi, Becky. Yes. So
Hi.
you said you.
Yes.
So you meant. You want me to stand up? You mentioned near the beginning about the importance of when it's separating orchestration and provisioning, and I think you might have mentioned something else which I missed, and something about making sure if you're deploying, you're not installing software. Are you talking about sort of separating the system upgrade from the final push of the software? Because deploy to me is at least installing some software, so how do you make that distinction?
Okay, I put things in three different categories. So you've got your infrastructure, you have your provisioning, and then you have your deployment. To me, if bringing your infrastructure up, it is bringing up your servers, getting everything together, making sure that all of your security groups, if you're using AWS and things like that, are correct and that everything can talk to each other. Provisioning is about, if you're using Docker containers, making sure Docker's on everything that you need it to be on. It's about installing RabbitMQ, all of that sort of thing. I've not really run into many situations when I'm deploying that I actually have to install anything, except for obviously the software you're deploying. So the distinction is a little bit subtle, and it can be kind of hard to spot. But generally speaking, if you are installing things, you're probably making a bit of a rod for your own back in the long run. Of course, you can't get away from installing requirements and things like that. But I kind of think that's a dependency of the project rather than the dependency of the system as a whole. So the only thing really to install is the requirements, I think. And if you can get around that, that's even better.
spoke about using Outstack for centralising monitoring. Did you find that there was quite a heavy burden in setting up the generalised graphing views for interrogating your centralised log?
Not as such, but then I tend to do things in a bit of a simplistic way most of the time. My team's quite small. We're working on actually improving that kind of thing so that we have better views, better ways of looking at our stuff. So that might even be something that I'm going to run into.
Any more questions?
What kind of technologies did you use to build your actual software, not just the deployment itself? Python libraries, RabbitMQ?
Oh, right.
What did you do?
A few things. I'm going to think what on earth I'm using in my tech stack. We're using Django for web stuff. We're using RabbitMQ to kind of push messages around our system. We decided to stay away from using APIs internally, like RESTful APIs internally, just because it's a bit more difficult. If the message doesn't get through, then you've got to write some code to actually handle that. We've got Postgres running for servers. We use AWS, so that's actually quite helpful. We also kind of strayed away from Python as well a little bit. We're using some Java here and there to do things that we need to have concurrency and very, very, very fast code. We've also got a little bit of Flask. It sort of grows, really.
Okay, we've got time for one or two more questions. I think one at the front here and then last one at the back there.
Talk about how to get like buy-in from obviously configure the manage and stuff. What was the key points that you justified the increase in time and complexity and paying to them? How did you get them?
I think I was a little bit fortunate because I went into a company that had a legacy project and it's very hard to change anything on it. So everything takes quite a long time anyway. It's also completely unscalable. It's kind of a little bit unmaintainable. So I was quite lucky in the fact that I could just point at sort of the existing stuff and going, we need to be scalable, we need to be international. Heck, we couldn't even run it on more than one server. So when clients are asking us, oh, can we have a local version of this? We'd have to say no. So I managed to justify it by basically saying, actually, all these business problems go away if we build it properly like this. And that was actually a really good justification for them.
Hello. Can I just say, good talk. It was, especially if it was your first talk in front of an audience like this, really good. I've been there and it can be very unnerving. So yes, good job. Can I just ask if you had an on-call rotation as developers, and if so, whether you cherry-picked different types of alerts to wake you up in the middle of the night versus what you cared about the next day, or if you don't have an on-call rotation as developers and you have someone else developing, the sort of dev versus ops question. Thank you.
We're a very small company, so I am the on-call. Which is kind of good and bad at the same time, because it means I have to make sure stuff works and that I don't get a phone call at 2 o'clock in the morning. So we don't deal with any on-call rotation at the moment, I should say, really, because we are pushing out to the other side of the world at the moment, which means we can't have 24/7 on-call support. We're going to actually get some help in for that, so I'm going to see how that goes, but the rotation will probably end up with me still, unfortunately. Does that answer your question? Or?
I think so. Anything about the
I think the question was about types of alert. Is that right?
Oh, sorry, types of alert. we try to make sure that we're getting sort of soft alerts via email, so that when I come in the morning, I can actually see if there are any sort of growing issues. If something has gone completely down, then it's just critical. That sends text messages, things like that, not just to me, to other people in the company, just in case I don't hear it or I don't receive it. Yeah, so we sort of just stick really with more soft alerts, as well as sort of critical issues, as well as uncaught errors, obviously. We use Sentry to sort of report to us what's been going on that we may not see because the error is just getting swallowed. Yeah, I really like Sentry. It's saved me a few times.
Okay, that concludes our session. We've got a half-hour break coming up. Your next set of talks will be starting at 11:15. And can I just say a great big thank you for Becky Lewis and her very first talk here at Pycon UK. Thank you, Becky.